Hello, welcome to General Chemistry. This is Chemistry 11:10. Make sure you're in the right class. Our textbook is OpenStax, and at the beginning of all of your notes, you will find a live link that you can click if you ever need to go to the textbook for reference. The textbook is free. You'll also see in the homework there are recommended textbook problems in addition to the eLearn problems. All of your notes are going to start like this, where you've got a link to the textbook chapter, and then you have a math reference page like this. This is just kind of the summary of everything from the chapter that might be useful. It's just all put on the first page as a reference. You'll find the same charts later on in the notes too. They're just combined together here. You're going to generally skip to page 2 for your notes for class. So these are some of the pieces of information you're going to need for this chapter. Let's get started. So this is your link, again, to OpenStax 1.1. First thing, chemistry is central. It's a central science. You might take a minute and look at all of the different fields that web off of chemistry, with chemistry being central. This might be a helpful reminder if you're in the middle of chemistry and you're wondering, why am I in this class? There's just kind of like some ideas of some other fields that link to chemistry. And no class is complete without a quick scientific method review. So this chart is really nice because it shows how cyclic some chemistry and some experimentation really is. So you've probably already knew this first step of the scientific method is that you're going to make observations, you're going to be curious. Then you form a hypothesis right here. There's your hypothesis. So it's not just a guess. It's actually something that's kind of logical based on what you've already researched. So you have some idea. It's not just a blank guess. And you think that this is maybe why something might happen and you need to further test it, and you're making a prediction. Now, here's the interesting part. You'll do more research to find the right experiments to run in chemistry. This is if you go into research in a chemistry field. So you're going to make some experiments. And here's the interesting bit. Very rarely do you end up going straight to the journals. That would be shocking, actually. What generally happens is that week after week, you go round and round, refining your hypothesis, running more experiments, and going round again, refining it again. Well, maybe the solvent you used was wrong. Maybe the temperature was wrong. Maybe the pressure was wrong. Maybe something wasn't pure. Maybe something had some water in it. There's all these things you have to rule out. Maybe this wasn't the best hypothesis, and you're going to go with a completely new hypothesis. But the reality of the scientific method is that it's very cyclic, and the majority of this time is going to be spent with people researching and researching and researching. Once they finally get the results that they predicted in their hypothesis and everything makes sense, that's when they're going to send it in this direction. Now, along the way, there's people who are going to check the information before it actually can be contributed. So in chemistry and in other fields like this, when people say they publish or they've sent research papers out, that means that they've gone into scientific journals. Now, once they're in a journal, there are two types of outcomes. And the first type of outcome is when you go in this higher direction, and that's when, after several people all contribute and add to your work, and you've added to their work, and everyone's made a lot of progress, observations can become law. So this is what happens. So for example, you might see a tree and you might see an apple fall down from the tree and land on the ground. That's what happens, that the apple falls. Now, the other direction is that you can also end up coming up with a theory. And theories are developed by people who have a lot of experience in this one specific area. They're developed by people who have a lot of publishing, and they're usually developed after a lot of argument. This is why the observations were made. And if we go back to the apple, one theory could be that there is a force called gravity, and that's what pulls it down. Now, this y can change, and in the older days, before everything was digital, people would publish a paper with a theory y, and then maybe 20 years later, someone would amend that theory, and that would be in a different journal article in a different section of the library on a different shelf. And you may or may not realize that that's what's happened when you've read some theory that someone else has. But now that everything is electronic, any amendments have little links underneath, and you can go and read what might have changed about a theory. So theories do not have to be absolute, and maybe this first theory wasn't gravity. Maybe someone noticed the apple before noon and they were like, oh, well, that's because aliens are pulling it downwards, right? Then something gets refined and they're like, no, it's a force. It's called gravity.